Hey everybody, this is Brad Dyke. How you doing? I'm reaching out to you to talk to you. The reason why I'm doing this video is about software. Some new ideas that you can do at home with some basic things. MySQL is a tool that is used for transaction log databasing. In other words, it monitors transactions from start to finish. Those transactions can be used for a variety of different things, and the company I work with, which is TradeCentric, uses that technology along with MariaDB and other resources to accomplish a lot of great things. What can a small database do for you at home on your back environments? Well, obviously any database can do your basic like inventory tracking, resource planning. You can do what's called power monitoring and send it into a database where it can tell you how much wattage you're utilizing in your test lab, and basically have a picture and a cost expectation that's being ran on a database kind of process. And as you want to know information per month, you type in a query saying, hey, on the month of January, how much wattage on average give me for 30 days? And whoop, it comes up on the screen and you got it. Can't do much with that, can you? No, not really. Nor can you do the very bad thing, and that is web crawl the internet and try to build your internal metrics database model, which would require most of the size of your home and hardware disk space to be able to track all of the endpoints in the web. Yes, I have met people who've tried to do that, and I've actually seen a datagram model of the web. So, what's in between? Okay, well, there are a couple of things you can do, and you don't have to do them in a transactional-based database system. You can just do them in general, which means they can be active state, it can be a meta model, a metadata state model, and or it can be a transactional / metadata model, and so on. In today's world, we're doing a few new things that are becoming the new standard, and one thing is data is no longer just data. Now, what do I mean by that? What I mean is data, a picture, a graph, a binary file, your security number in a hidden encrypted text file. Whatever it is, it has a header, an ender, a size requirement, and a date. And that's when you go out and you do a list command in Linux, or you do a dir command in Windows, and you bring up the list of the information of the files you have in there. The header has the file name in it. It tells you, hey, I'm blah, 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 text file. And then beyond that, it says created on date, blah, 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 and I am so big. Okay, that is what we call data. The new form of data is known as metadata, and it is not the same as database style metadata. It is a binary file with meta headers in it. And the meta headers, it's just an example. The term, I think, is different, but basically there's a header on the front end and there is a header on the back end, and they contain policy information, additional support information, as well as control, and as well as termination and retention. So in other words, if you have an environment that has metadata basically built into its setup, you can actually tell all your cache files to definitely be dead in under 24 hours or 2 hours or 20 minutes or whatever. Because of the cache nature of files, they're cache. So you can actually say, hey, all of you guys that do nothing for me except to temporarily hold data, I want you off my hard drive ASAP. And this metadata model, which we also refer to as GDPR, which uses basically global policy storage processes, or it's a storage system known as GPFS, but it's no longer called GPFS because of a big battle with IBM, blah, blah, blah. Point is that GDPR, which is a standard that exists within the European countries, and it's also in the US, but not heavily enforced, puts your data into a metadata model that can allow them to implement what's called a control policy. It allows you to put what's called a handler policy, an access policy, and the retention and deletion policies. Why? Well, the nature of that is to delete data when it's not needed, or when it should not be available or should be retained. It does matter because when you look at a hard drive space, Do you realize that you only use about 3% of your hard drive space in retention? Now keep understand that a 2 terabyte drive, 3% is a lot of data. That's 30 gigs of data, right? So the point is that when you're looking at an environment like this, and you realize how little you have, and you don't want people to see your data, and you want to make sure that I only want it for so long, you have the ability of doing that. And this is something that can be set up in a home server environment, because what is the most common problem with your NASs out in the world? May they be true NAS and a Dell 720 array with a EMC SSD storage disk array solution like I've got. The common problem is you have to add more disk. Why? Because the data you're retaining, you're not sure its value. And if you're not sure of its value, you don't have to actually want to ever delete it, because you just want to make sure it's there as a backup. Right? Right. Hence the mistake that many people make when they have a NAS in their home to hold photos and profiles and backups of systems and so on, that if they don't put a metadata model on top of it to manage it basically and make sure it's ultra secure, that's the other value, because that access policy really locks things down, to even to the point where the encryption state across the board is staggering in the sense of commercial level encryption, not military grade. But overall, how do you go about, managing your data if you don't have a way to do that? And I think that this is a really cool way to do that. And the other cool detail about this is it's not a database. It's an implementation controller on the actual disk space. So it does what it needs to do, and it does it very similar to a database, but it is not an interactive database. And this is something really cool that people should investigate into, because it adds 4 layers of additional protective functionality to the ownership of your data. Now, let's say the fact what it is. A picture is a picture. You're right. And a picture is one of those things, no, you don't delete. It's my baby on her 2nd year birthday party having cake and smashing it in her face. Great picture. Awesome. Really cool. I want to make sure nobody makes the mistake of deleting that. See what I mean? Reverse the policy controls, and those photos cannot be deleted off that environment for any reason unless you have the key that releases it. And those are the kind of things which are out there. So what I tell you in this software video presentation that I'm doing today is take a little bit of time, step away from the Docker, step away from Commission, or whatever you want to call it, step away from the web services and DevOps. Take a picture of this environment. Now, once you see the value of it, here comes the kiss of death. You can't deploy it in a complicated model. What do I mean? Well, GDPR has a value, and anyone can install it anywhere. It's native, it's pretty easy to build, and it's pretty usable. But when you start to build your policies and you start to stage the way you want it to function, you have to understand the nature of that setup. Sit down on a piece of paper and draw it out. What kind of policies do you want to put in place? Who should have rights? What type of rights does a file need to have? What type of retention? Is it never delete, or is it 5 years, 2 years, a couple of months? That's great for like doing backups. So once you do your 2nd backup of your environments, the 3rd oldest backup is removed automatically, and you don't have to do any of that work yourself. And then of course the end game, which is the deletion strategy, which will go through and police up your capacities. Now, when you diagram that out based on what you've learned, make sure you keep it simple, stupid, KISS format. Very important, because you're talking about hundreds and if not millions of files over time. And that's an important detail. Complications come quick. Even when you make it as simple as possible, it can be a little complicated. So keep it simple design strategy in your head when you do this. Then it will make sense and you won't have to come back to it for a while. That's the other problem with services that just run, like Binds, DNS, and other services like Winds and so on. They run in the background quietly doing their thing, and eventually you forget about them. Well, unfortunately with GDPR, it's one of the key services out there that you cannot step away from. It's going to send you information. It's going to tell you about penetrations. It's going to tell you about unauthorized accesses and so on and so on and so on and so on. So you should set up an email rule so that you're getting that information when you're strategizing your deployment model. That's right. We're going to generate a little bit of email. Not a lot, but some. That email traffic will keep you in the loop of what's going on and can give you that security level that you're looking for. Lastly, encryption. I'm not a fan of encryption. I use it. I've used all kinds, military, commercial, and so on. Use it only when you think you need it. Don't encrypt everything. It's just not necessary. It's something that has a defined role and should be handled in that manner. Remember that when you're doing this, because encryption has a way of wreaking havoc if it's just the only thing out there. Now, when we talk about encryption, we're talking about at the software level, an implementation that might be like a KMS style or a deployment key or something like that. Hardware native encryption is completely off the board. If your hardware does native encryption, that means if it goes on the hard disks, it's encrypted. If it leaves the hard disks, it's not. So if it sits on your hard drive array through the encryption hardware algorithm built on the controller of your disk array, it's just localized. So all that does for you, in a nutshell, is if I go down there and I pull all those hard drives out and I put them into another controller somewhere else, and I try to establish the RAID group and get everything set up the way it was on my system, it craps out no matter what, because the encryption key is on the localized controller on the unit and you didn't take it with you. Or it's in a place where you can't take it. That's the value of at-rest encryption, because it's a serious pain in the butt to steal a whole rack, right? So with that being said, there are really some cool things out there that you can start to use in your lab environment that can add that level of reliance, support, and not so much maintenance, opposed to you spending hours and hours and hours and hours a year navigating and managing your stuff. Now, the last part of this is endpoint usage. And what that basically means in a nutshell is endpoint usage basically means to everybody in the room that when I have an endpoint coming in and using GDPR metadata disk storage usage, what they do happens automatically. In other words, they have to do nothing. All they have to do is establish their initial connection and get to that GDPR petition that's out there and start using it. And this is a great value, because if any of you have ever set up what's called endpoint to endpoint encryption environments, super pain in the butt. Many times you're not allowed to talk about it because you're under an NDA, you're under some type of non-disclosure about it, and most of us never ever talk about it. But the point is, what a pain. That's the point. So in general, you're working in an environment where you have the ability to be fairly flexible, because you don't have to be an expert as a user on GDPR. You just know that your data is safe on that tiered system, no matter what, and that's what matters. And lastly, just as a side note, these array environments, if you use something called file synchronization, don't have to be operational. See, that's how you defeat hackers. Hackers make the assumption that you just have it out there. Yeah, no. That pretty much is a no-go, because once we're done and the syncs are done, the array is completely taken offline and just physically disconnected. Why? Well, two reasons. One, I'm not rich and I don't want stuff just running to run and having no value, and there are periods of time where nobody's going to do anything to that disk. So I'm going to power it down to keep the life of the capacity more effective. And this allows my IT environments to be ultra high secure, because unless you know what I did on these boxes, they're powered off. You don't know how to power them up correctly in the right proper sequences for them to do what needs to be done, and so on and so on. It really wreaks havoc on hackers. I have dealt with so many, I don't even care to discuss this. But the point is, the value that this brings is you can actually set this up really cool to go out to your clients, synchronize with their folders, pull everything down, power off, shut it up, disconnect it, totally secure. And 2 months later, you power it back up, and you do your thing. And I like to do it I only do it about three times a year, and it works. All my family's data and all of that is all secure and buttoned up, and it's going nowhere. So, with that being said, have fun. Pitch and pivot. Think outside the box. Software is just that. Now, this video is about new tools that can come into our local test labs and can be something that which we can play with. This is Brad Dyke signing off. God bless. Have a great weekend and take care.